It has started picking my own voice. That started, Abi. All right. Good morning, everybody. Now, the topic for today is design of compression members. I'm starting with the explanation of what compression members are. Yes, Shele. Okay. A compression member is a structural member which is straight, right, and subjected to two equal and opposite compressive forces. A compression member is a structural member which is straight and subjected to two equal and opposite compressive forces. I said a compression member is a structural member which is straight and subjected to two equal and opposite compressive forces. Two equal and opposite compressive forces applied at its ends. Applied at its ends, depending on the position of the member. Let me come again. A compression member is a structural member which is straight and subjected to two equal and opposite compressive forces applied at its end, depending on the position of the member in a structure. So what this is trying to tell us is that, you have a member. This member is straight, right? Now, it is subjected to two equal. That is, this is F, right? Two equal but what? Opposite forces applied at its ends. So now, you have different types of compressive members. Number one, strut. Strut. S-T-R-U-T. Strut. Number two, column. Number one, strut. Number two, column or stanchion. Column. Stanchion is spelled as S-T-A-N-C-H-I-O-N. Or post. Number one, strut. Number two, column or stanchion or post. Number three, principal rafter. Number three, principal rafter. And number four, boom. B-O-O-M, boom. So now, I'm going to explain where you can find each of these members in a structure. Number one, strut. As building students who has been dealing with building members, basically, where can you find struts in a building? In your roof trusses. Are you with me? So write this down. For struts, these are compression members. These are compression members used in roof trusses and bracing. These are compression members used in roof trusses and bracing. They are small and they are either vertical or inclined. Let me come again. These are compression members used in roof trusses and bracing. They are small and they are either inclined or vertical. Are you with me? Now, that's what a strut is. Now, column or stanchion or post. These are subjected to heavy loads. Columns. So, your column carries what in a structure? What rests on your columns? What rests on your columns, building students? Beams. What rests on your beam? Slab. So it's saying that this column, it is subjected to what? Heavy loads. So these are subjected to heavy loads. They are vertical compression members. They are vertical compression members. Every column is vertical. Every column is what? Vertical. They support the floors in a structure. They support the floors in a structure. Now, the third one, principal rafter. Principal rafter. The principal rafter is a. Should I come again for column? These are subjected to heavy loads. They are vertical compression members supporting the floors in a structure. Now, principal rafters. This is a top chord. When I mean chord, C-H-O-R-D. This is a top chord member in a roof truss. This is a top chord member in a roof truss. This is a top chord member in a roof truss. Then the last one is boom. Now, the reason why we are not familiar with this word boom, which some of us should be familiar with actually from building maintenance, whereby we drill plants and we drill cranes, right? This boom, you can find boom in cranes. You know what cranes are, right? Good. So boom, this is the principal compression member in a crane. This is the principal compression member in a crane. So, for the sake of this class, the main thing we will be focusing on will be struts and columns. For this course generally, when we are talking about compression members, the main thing we'll be focusing on will be what? Struts and what? Columns. Are you with me? Good. So now, there's a lot of theory with this course, not too much actually. I'll send the PDF to you after this class. So you can read up on it. I'm diving straight to the calculation. So now, very good. So these compression members, like I said, the design is divided into two. You have design of axially loaded members. Axially loaded members, that's the first one. Then the second one is members subjected to axial load and bending. So what we will do is we have two subtopics under this design. We design for two things. There are two ways your question can come out under this design of compression members. Axially loaded members and then axially loaded members and bending. So now I'll treat it step by step because there are steps. For axially loaded members, you have 12 steps to solve. Why for the one with bending, I think you have about 16 or 17 steps to solve. Are you with me? All right, good. Femi, pause your kino. When are you cleaning? Eh?